Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we are from Group 6 wants to present about our project, which is Sungai Kepong Bridge. Our group consists of 4 persons, which is Muhammad Al-Amin bin Muhammad Abdul Rashid, Nur Syazwani binti Muhammad, which is me, Lee Pei Shan, and Wong Yi Won. This report briefly discussed about the element, technical, and structure of the bridge construction on the highway at Sungai Kepong Bridge, laluan 64 Jalan Benter, Jerantut, Maran, Fasa 3, Segment 1, Pahang. This route connects with the Benta in the west to Maran in the east. All basic components are located within 3 main bridge areas, such as foundation that use bore pipe, substructure which is piers, abutment, and superstructure which consists of decking, girders, slab, steel truss system, cable stay, or cable suspender system. In order to construct this highway bridge with higher level of safety for the passenger that pass on it, all of the components, structure design, and equipment plans used need to be taken considerately. Okay, the location for this project is at Jalan Benta, Jerantut, Maran, Fasa 3, Segment 1, Pahang Darumamor. This bridge that built in this project is called as Sungai Kepong Bridge. This Sungai Kepong Bridge is located on a highway which is en route Jerantut to Maran. This bridge was built along the highway which is Lebuh Pantai Timur. As we can see at the picture, there is a circle to show the location of the bridge. The position of the bridge is located along the highway from Jerantut to Maran. And for the cost overall of this project is cost around 22 million. The bridge is built by concrete, and they also have a geofabric wrapping at the bottom of the bridge. This bridge also uses piling as their foundation. The type of project that our group chose is a project that carry out the construction of bridge at a highway. These public roads of bridge connect the transportation between the Jerantut and Maran in Pahang. This bridge has been designed with strong load capacity to support the large number of vehicles on it. Next, I want to show the client's background and consultant team. For your information, this project is belong to Jabatan Kerja Raya Malaysia, and they also provide the consultant team. All of the consultant team is from TKR. As we can see here, there's a senior director of Road and Bridge engineer, and all of the consultant team is from TKR. Next, I want to brief shortly about the design. As you can see in the slide, it shows that sectional plan of the bridge. This bridge provide 600 mm diameter board piles and use 30 meter T-beams poly integral. For your information, the girders of this bridge is used T-beam, and it consists of pressurized anchorage used to make sure the bridge can lift the beam strongly. And this structure of the bridge has 2 abutments, which is use 7 numbers of pi to support it. Next, I want to explain about the concept of the bridge. As we all know, bridge is a structure that connecting 2 places with a jointing road or railway that allow the people or a passenger to pass through it over a stream or obstacle. It can carry the vertical moving heavy loads on it and allow any heavy vehicle to pass through. Before the construction of the bridge, there are several considerations that needs to be taken during the planning and design phase. The first consideration that needs to be taken is the type of bridge. Before the construction of bridge, we have to know first what is type of bridge that we needed, because there are so many types of bridge in this world, such as beam bridge, truss bridge, and many more. And later I will explain more about the type of bridge. Next is the ground condition of the site. Ground condition for the site construction of bridge also need to be identified clearly by carrying out the soil or geotechnical investigation. This method is so important because it is to determine the excavation method, equipment used, and the type of foundation for the construction of the bridge. Then, the strength or load capacity of a bridge also need to take consideration in the construction of the bridge. As we all know, the main function of the bridge is to carry the moving loads on it. Thus, the high load capacity is very important to ensure the safety for the users. The failure of the bridge in order to support the heavy loads will cause the collapse of the bridge and injuries to the users. And last but not least, the consideration that has to be taken is the testing for the bridge. There are so many types of bridge in this world, including a girder bridge. Girder bridge are also known as a steel beam bridge. Girder bridge is a bridge that uses girder to support the deck. Girders are made of concrete or steel. When a girder is made of concrete, it is called as beam. The concrete box girder is used by many shorter bridges, particularly in rural areas, where they may be exposed to water overtapping and corrosion. Beams itself are the main support of the deck in a beam or girder bridge and responsible for the moving loads down to the foundation. Next, the type, shape, and weight of materials all influence according how much weight a beam can carry on. Next is cantilever bridge. Cantilever bridge is a bridge construct using cantilever. Then the cantilever is made by steel trusses or pre-stressed concrete girder. The cantilever may be simple beams or small footbridge, but large cantilever bridge built to handle road or railway traffic. This type of bridge suitable for pedestrian, trains, and motor vehicle. Next is arch bridge. Arch bridge is one of the most common type of bridge, which came into use more than 3,000 years ago and remained popular until the Industrial Revolution. And the advent of material enabled architects to build other modern bridge designs. Okay, the basic concept of the arch bridge is in a curved shape, which does not directly drive down the loads, but instead transmit them to the support at either end along the curve of the arch bridge. Then belly bridge. Belly bridge is a bridge that built by trusses. Belly bridge has the advantages of not needing any special assembly or heavy machinery to construct it. Without the use of crane or any equipment, the wood and steel bridge components were compact and light enough to be transported in truck or raised by hand into position. The bridge were sufficiently strong to hold the tank. It is also continued to be used widely in structural engineering construction. Next is suspension bridge. Suspension bridge is a type of bridge in which the deck is hung on vertical suspenders under suspension cable. Suspension bridge systems' fundamental structural components include stiffening girder or trusses, and a main suspension cable, main towers, and cable anchorage at either end of the bridge. The weight of load is supported by vertical suspenders, and this type of bridge cannot support the heavy weight that pass on it. For example, in Malaysia, we can see the suspension bridge is located at Sungai Kepong theme park. Lastly is the cable stay bridge. Cable stay bridge is a bridge with one or more columns, or can be called as towers or pylon, with cable that support the bridge that directly. Okay, there are two primary types of cable stay bridge. The cable in the hub design are almost parallel. This is achieved by adding them to the tower at a different stage. The loads for this bridge is carried by the cable, and this type of bridge is cheaper to build compared to suspension bridge over a short distance. And there are advantages for constructing this type of bridge because it's look modern and exclusive to the country that has built this type of bridge, such as Pulau Pinang. Next is method used in bridge construction. As we all know, most of the highway beam bridge are made of concrete and steel. It is also commonly used in a bridge project superstructure such as for pre-stressed concrete beam, deck, curb, and others due to the most function of concrete, which is it has a good strength to resist compression. Next, concrete also extensively used in the bridge foundation because foundation is function as the main base to resist the load. So, of course, the concrete is a suitable material to construct it. Other than concrete, steel is a type of material that's suitable use for construction a bridge because steel is widely used for armor expansion joint, bearing, floor beams, girder, concrete reinforcement bar, road barrier, and trusses. Asphalt is a material that used to protect from water or disease, salt or metal, timber or concrete decks of the bridge. And lastly, the thinning layer of highway bridge may made from bituminous material. Next, let's look into a technique that commonly used in construction of bridge. The first is cast in situ or precast method. When it is hard to transport the prefabricated element or structure of the bridge, in situ method is the more applicable. Okay, why? Because the concrete structure is poured in place and form the substructure prior to the fabrication or superstructure of the bridge. Next technique is precast method. Refer as the structure or element is fabricated in plant and delivered to site. This method produces more accuracy in quality standard, and where segments can be assembled in conjunction with early field construction activities. So, the element that include in the precast concrete is such as precast beam, decks, and segmented decks. Then, balance cantilever method. This method is suitable to apply for all the bridge structure with span start from 50 meter to 250 meter. This also approach save all temporary work and enable bridge to be constructed at great height. Here, segments are respectively connected to opposite ends of cantilever backed by piers. Next, span by span casting method. This method, which is available for long bridge and viaducts with a single span of up to 60 meters. Ducts are started at one end and continuously installed by placing all of segments at the other end of the. Number 5 is incremental launching method. In a sequence of increments, incremental launching process is usually carried out with the bridge deck with a 250 meter length or greater than that. It is used both for the construction of continuous concrete and steel girder. And last but not least is cable stay method. This method is a straight diagonal tension cables run directly to one or more vertical towers to bear the weight of the deck. Okay, by vertical compression, the towers reach the cable force to the foundation. Then the deck is often forced into horizontal compression by the tensile forces as in cable. Okay, next let's look into factors that cause bridge failure. Okay, the first is design and manufacturing defect. Okay, the design that construct on the bridge must suitable with the load capacity. Next is improper or neglected maintenance. So with more strict inspection and maintenance routine, many bridge failure may have been avoided, and plenty of collapse that occur for other causes are caused by inadequate maintenance. First of all, this bridge has three components, such as foundation, substructure, and superstructure. Okay, for the foundation, our project used board pipe as the foundation, which is 600 millimeter. Okay, this board pipe used internal steel cylinder as temporary casing. Then this pipe used reinforcements such as 12 mm diameter high tensile as pillar and 25 mm diameter high tensile as the main reinforcement. Okay, the second element is abutment. Abutment are the components at the end of the bridge that provide protection for it. In our project, Sungai Kepong have two abutments, which is abutment A and abutment B. Both of it use 7 number of pipe below it in vertical. Okay, for the piers. Piers is actually known as the intermediate heights for the multi-span bridge superstructure. So for this bridge, they use 7 numbers of 30-meter diaphragm beam as the piers. On top of that, there will be a span of deck, and the diaphragm of beam is to provide stiffening impact to the deck, which are not situated directly on top of bearing. Okay, lastly is the girder. Girder is a main support for the deck. So the function of the girder is responsible for transferring the load down to the base or to the foundation. So the height of a girder is the most significant factor to affect its load capacity. Next is deck. Deck is classified as roadway of a bridge that the functional area allows vehicle or other pedestrian to cross on it. So deck has two parts, which is the shoulder and carriageway on the deck. So our project is Sungai Kepong Bridge constructed by reinforced concrete for the deck and supported by the T-beam girder. So it used pre-stress method for the tendon. The third factor is flood. Extreme flooding can cause the overflow of rivers and creeks, accumulating debris such as trees, wood, and parts of houses. So the elevated water level smashes the debris onto the bridge as the river flows under a bridge. So the bridge may be brought down by the weight of the stack up combined with the force of the water flow pressing on it. And lastly, infrastructure issue. The ultimate cause of the incident was an overweight load traversing the bridge.
Assalamualaikum. My name is Muhammad Al-Amin bin Muhammad Rashid. I'm going to continue the presentation. I will briefly present about process of construction of Sungai Kepong Bridge. Okay, firstly about the process of site clearance. We need to remove all the tree and the tree stumps by using the excavator on the surface of the site. Then all the topsoil layer will be removed by using the bulldozer. All the removable soil will be transported out by the dump truck. Okay, next, the process of bore piles construction. Firstly, we mark the bore piles position using the steel pegs. Then, we install the temporary guide case for drilling process. We use the 12.7mm thick with 600mm diameter of the casing, and we install it using hydraulic casing oscillators. Next, we drill the boreholes to the soil into 16 mm depth. Next, we install the steel cage with reinforcement bar 25 mm high tensile as the main bar and 12 mm diameter as the spiral reinforcement. Next, we pour the concrete into the steel cage. We use the concrete grade C32/40. Actually, this concrete grade is good for foundation. Okay, lastly, we cut the pile head using the hydraulic splitter. Okay, for the third process is process for abutment construction. And firstly, the lean bedding material at the base. We use the 600 mm thick permeable layer on top of that, which is the 50% of river sand and 50% of crushed aggregate. Okay, next, we will apply 50 mm thick of the lean concrete for the base. Then we lay geofabric wrapping for the filtration and others on top of that. Then we apply again 150 mm thick of lean concrete on top of the geofabric wrapping. Next, we install the fixed heavy duty shutter, and this was used because it was an extra safety and support for the heavy duty. Next, we construct the 150 mm diameter of the perforated seepage pipe. Then we set out the rebar and reinforcement, and we use the 12 mm diameter and 16 mm diameter of the high tensile reinforcement. Next, we pour the concrete and using the same concrete grade also. Then the shuttering will be applied and carried out. Next, we apply the bituminous coating, and this bituminous coating used as a waterproof function. Okay, next, a well-graded granular filling used as the backfilling process. And lastly, we will install the disc bearing between the abutment element and the T-beam girder. Okay, next is the process of T-beam girder construction. Firstly, we set up the rebar cage fabrication, and this rebar cage is used for side support for the girder at the both end. Then we assemble the precessed concrete strand into the duct. The duct is actually the hole or a place which is the PC strand inserted into it. Then we pour the concrete once the PC strand is ready. Once the concrete is pure and reach the required strength, the tendon will be released. Then we tensioning the pre-stressed concrete strand by using the stressing jack and the stressing pump. The pre-stressing system shall be the BBR Kona Compact multi-strand system. Then we install the anchor to lock the PC strand for the pre-stressing condition. Then we cut the pre-stressed concrete strand if there are any exit of them. Lastly, the grouting shall be carried out, and the grout shall be mixed in grout mixer and covered with concrete to avoid from erosion. Okay, next is the process for deck slab construction of the bridge. Firstly, we will set up the rebar cage fabrication for the deck, which use the 12 mm diameter high tensile and 16 mm diameter of high tensile for the steel bar reinforcement. Then we set out the formwork and install the rebar cage into the top of the deck slab. Then we will pour the concrete grade 40 into the formwork structure and over the rebar cage and ducts. We will test the strength of concrete when it's fully hardened to make sure the concrete is ready to use. Then we will remove the formwork from the deck and start to install the extension joints and the pipe ducts. As the finisher, we will apply the tar when all of them, such as extension joint and pipe duct, are installed. Okay, for the process of wing wall construction, firstly we will apply the 50 mm of the link concrete, which is the grade is 50. Then we set out the formwork for the base of wing wall structure, and we install the 60 mm diameter and 20 mm diameter of the high tensile for the reinforcement. Then we will pour the concrete into the base of formwork structure. Next, we will set out the scaffolding to support the wing wall structure. Then we set out the formwork for the wing wall structure. Then we install the same reinforcement, which is the 60 mm diameter and 20 mm diameter of high tensile reinforcement, and the spacer we will place into it. Then we will pour and vibrate concrete into the formwork structure, and we will use the concrete grade 40. Lastly, we will remove the formwork once the concrete is hardened and apply the finishers such as paint to the wing wall element. Then, the process of precast parapet wall construction. We will use the precast parapet wall for the bridge. Okay, firstly, we will mark the position of the parapet wall will be placed. Then we leave the parapet wall using the crane and place to the fixed mark placed. Then we install adjustable prop to the parapet wall so that the parapet wall will not be fall. Then we will install the formwork at the reinforcement jointing between the deck slab and the precast parapet wall. And lastly, we will pour the concrete on the formwork prepared and leave the concrete to cure and harden. Okay, for the last process of this bridge construction is the drainage system construction. Firstly, we will cut the pipe to the required length. As for the vertical pipes, required to 600 mm long from the deck to the ground. Then we will lay the horizontal pipe before construct embankment by using the 90-degree elbow pipe to connect with the horizontal pipe. Okay, lastly, we will install the vertical pipes when the deck slab is constructed. We will use the PVC pipe for the horizontal and vertical pipes. That's all from me. Thank you.
The type of material used on the construction of bridge. First is the steel bags used to set up the position of piles, and it will be easier for them to drill the boreholes. The cost of steel bag is 54 cents per nose. For the temporary casing, which is 16 meters long, the casing will use as permanent so it will not be pulled out. The cost of temporary steel casing with 600 mm diameter is 2,060 ringgit and 25 cents per nose. For the steel cage with a reinforcement bar of 20T25 as the main bar and 312 spiral reinforcement and 20 mm pitch will be installed into the boreholes. This means for main bar, they use 20 number of high tensile which diameter 25 mm, and for spiral reinforcement will use high tensile which diameter 12 mm. The cost of reinforcement bar which diameter 25 mm is 2,326 ringgit and 20 cents per ton, while for the spiral reinforcement which diameter 12 mm is 2,495 ringgit and 60 cents per ton. Other than that, the labor used concrete grade C32/40 with water ratio of 0.5 for concreting the bore piles. It usually used when large heavy weights will be applied to a small area such as these bore piles. The concrete also will be tested to make sure that the slump was between 125 mm to 175 mm, which approved super plasticizer. The cost of concrete grade C32/40 for ball house is 361 ringgit 45 cents per meter square. The cost of 125 mm to 175 mm approved super plasticizer is 76 ringgit 25 cents per nose. A steel pipe with the diameter of 250 mm is lowered down to the borehole so that the concrete can be poured into the holes. It's called pipe of sonic logging. After the pouring concrete process is completed, the steel pipe will be pulled out. The cost of sonic logging pipes is 79 ringgit and 51 cents. For the base of the abutment, first they set up a layer of 600 mm thick permeable layer, 20 to 40 mm mix of 15% river sand and 50% of crushed aggregate. The cost of river sand is 52 ringgit 50 cents per meter cube. The cost of crushed aggregate is 25 ringgit 75 cents per meter cube. After that, the workers will pour 50 mm thick of linked concrete with grade C32/40 on top of them. Then a layer of geofabric wrapping will be installed on them. The cost of linked concrete is 215 ringgit per meter cube, and the cost of geofabric wrapping is 25 ringgit 14 cents per meter square. To let water to flow easily, they install the 150 mm diameter perforated seepage pipe by 26 ringgit 71 cents per meter. After that, they will set up the reinforcement for the structure of the abutment, as for the starter bar formed in horizontal bar and U-bar formed in vertical bar. They use reinforcement with diameter 12 mm and 16 mm but different in amount of number for sure. The cost of reinforcement bar with diameter 12 mm is 2,495 ringgit 60 cents per ton, and the reinforcement bar with 60 mm diameter is 2,361 ringgit and 50 cents per ton. In the construction process, they will apply a layer of bituminous coating to be a waterproofing function. The cost of bituminous coating is 36 ringgit. Then well-graded granular compactor fill needed for the backfill of the abutments, which cost 79 ringgit and 50 cents per ton. Lastly, they will install the stick bearing between the abutment and T-beam girder. The cost of stick bearing is 35 ringgit per piece. The T-beam uses a preset steel tendon that attach into the duct and then cast with the concrete. The cost of preset steel tendon is 3,306 ringgit and 65 cents per ton. After the tendon being released when the concrete hardens, the anchor will be installed to lock the strand, which the cost of 32 ringgit and 26 cents per set. And the grouting will be carried out and covered with the concrete to avoid form erosion. They will mix in the grout mixture and have a composition of 150 kg bag ordinary Portland cement. The cost of Portland cement is 90 ringgit for one bag in 50 kg. After the concrete is full cure, install the extension joints and 100 mm of PVC pipe piping at the deck slab. The cost of extension joints is 725 ringgit and 85 cents per meter, and the cost of PVC pipe piping is 11 ringgit and 38 cents per meter. The element parapet that being functioned as a side protective barrier on the bridge was cost 4,820 ringgit per set. Next, they use many types of PVC pipe for this drainage pipe. They are 600 mm long and 150 mm diameter PVC vertical and 100 mm diameter for the horizontal pipe and 90-degree elbow pipe. The cost of 100 mm diameter PVC pipe is 11 ringgit and 38 cents per meter, while the cost of 150 mm diameter PVC pipe is 24 ringgit and 90 cents, and the cost of 100 mm 90-degree elbow pipe is 15 ringgit and 50 cents. There was a type of equipment used in the project of Sungai Kepong Highway. First, excavator, which used to excavate and lift a big amount of soil in a specific area. When digging the soil, the bucket of the excavator will be cut into the ground and pulled backward to dig out the soil. In the project of the Sungai Kepong Bridge, the excavator used is a crawler excavator, and the market price was 169,888 ringgit, and for rental cost was 780 ringgit per day. Second, the bulldozer is a heavy machine which used for the removing of unwanted soil surface by cut and push the ground surface. It can help to spread out the soil to the surface and clean the side surface by remove the bushes and unwanted soil level. The crawler bulldozer is used in our project to clean the unwanted topsoil layer for the working sites. The price for the bulldozer is 78,000 and rental cost was 546 ringgit and 67 per day. Third, the dump truck is to transport the material to site and transport the unwanted waste away from the site area. The market price for the dump truck is 28,390 ringgit for the rental fee. Fourth, the hydraulic casing oscillator used to insert the casing to the position which is ready for the drilling of borehole. The casing will be fixed and held by the grab clamp on the equipment. The clamp will hold tight the casing and force the casing thrust into the ground by rotate and turning it right and left. In our project, hydraulic casing oscillator is used to install the temporary guide case. The market price for this equipment was 155,610 ringgit and 15 cents, and the rental cost was 2,226 ringgit 12 cents per day. 5. The rotary drilling rig. The borehole for the bore piles foundation in the Sungai Kepong Bridge project is drilled by using this equipment. The rotary drilling rig drill the hole by using a drill nozzle with a helical screw design. It will insert into the ground by rotation and the soil will be excavated out. The market price is 251,007,545 ringgit. For the concrete mixer track, used to mix and aggregate ready-mix concrete and transport it to the site area at the same time. It has the high capacity to keep the large amount of concrete and it can speed up the working progress on site. This is because the large amount of fresh concrete can be used immediately as the truck reaches on site. It costs 107,000 and range 165 ringgit per day. For the hydraulic splitter is to use as an equipment to break a hard rock or hard stone. In our project, the hydraulic splitter is used to cut the power head of the bore pile by using hydraulic splitter. The works of cutting the concrete power head can be carried out without too much noise and dust. It costs 12,952 ringgit per set and range with 396 ringgit and 65 cents per day. Stressing jack or stressing pump is used to tension the tendon in the preset 3-beam girder for the Sungai Kepong Bridge. A hydro pack will connect to the stressing jack and supply the power for the jack to the strength until the required level. After finished stressing, the jack will be removed and continue to the installation of the anchor and pouring the grouting. The market price was 4,047 ringgit 50 cents per set and can be ranged with 303 ringgit 56 cents per day. The crane hard wire and PC strength cutter was categorized in electric power cutters. The function was designed to rapidly and effortlessly cut hard materials such as PC strength, hard wire, and spring grades. It features a powerful electric motor to drive an integrated hydraulic pump to generate 30 metric tons of force. This compact design allows to use across the workplace and minimize heavy pumps and hose merely plug in and cut. The market price was 16,440 ringgit 50 cents and can be ranged 184 ringgit per day.
Beside of concrete mixer, the Sungai Kepong Bridge project also used grout mixer which fully uniform mix and quickly made into mix slurry. High-speed cement grout mixer mix various types of grout which can include cement, bentonite, and sand. For the project of Sungai Kepong Bridge, the grout mixer used to mix a grout mixture to cover with the concrete to avoid from erosion. The market price for this equipment is 23,711 ringgit and 10 cents per set and can range with 146 ringgit and 60 cents per day. The electrostatic powder coating used in the Sungai Kepong Highway Bridge was categorized in manual powder coating machine. This method of application is used spray gun which applies an electrostatic charge to the powder particles that are then rolled to the grounded part. It costs 2,919 ringgit and 53 cents and can be ranged with the cost of 363 ringgit and 36 cents per day. Followed with the vibratory compactors, which main function is to create a dense substrate for the lowest maintenance and running cost of compacting sand, gravel, rock fill, and paving stones. In the project of Sungai Kepong Bridge, this type of compactor was used to compact the subsurface of the back slab of the abutment after backfilling work had been done for the abutment. The cost was 2,016 ringgit and 25 cents and can range with 160 ringgit per day. The hydraulic power packs for multi-strength with decent aesthetics and easy to maintain was used in the project of Sungai Kepong Bridge to create an oil flow. pressure will be built up when the oil flows get resistant. The advantage of this machinery used for the project was with pressure control valves on the panel, maximum pumping pressure, hence jack lifting power, and can be preset or adjusted whenever and wherever. It cost 10,686 ringgit and 13 cents and can be ran with 304 ringgit per day. The gasoline concrete vibrator was working with concrete vibrator shaft, which is suitable for the commodity concrete. During its setting time, the use of vibration to support concrete has proved a worthwhile approach that helps with long-term durability. The market price for this equipment is 1,169 ringgit and 42 cents and range with 176 ringgit per day. Therefore, the 5.5 kW Robin engine EY20 gasoline concrete vibrator used in the project of Sungai Kepong Bridge aid in push the trapped air out of the cement mixture, leaving a compacted and smooth slab. Followed by the gantry crane used in the Sungai Kepong Highway Bridge, which lifting the reinforcement bar or rebar cage for the beam girder and deck slab. The gantry crane can lift, drop, and shift horizontally within the working radius in required to conduct the cargo lifting. It was easy to control, no need expert technician to operate for it and operate freely on the ground. The market price was 100,000, 8,012 ringgit and 50 cents. It also can be ran with 710 ringgit per day. The last equipment used on the project is a truck-mounted crane with telescopic boom using a hydraulic winch and by lifting and lowering the boom to lift the precast parapet. The maximum lifting capacity is 6.3 kg with maximum pressure of hydraulic system with 20 MPa. Telescopic boom trucks increase the ease and use of a construction site for lifting parapet, enabling every smooth and direct movement. The price for this truck was 116,942 ringgit and 50 cents. It also can range with price at 784 ringgit per day. Next, for the type of labours on site, it was categorized in skilled worker and non-skilled worker. Skilled worker is a person that is expert in doing work. They have a special requirement and skill to do it. For example, skilled workers are carpenter, cement builder, bricklayer, mortgager, roof builder, glass maker, and so on. The wage rate per day for skilled worker is expensive than the non-skilled worker, which depend on the skilled work that labor do. Non-skilled worker is a general labor that not requires special skill to do the job. The example of non-skilled workers are labor that lifting wood and stone, mixing concrete, and helper for the skilled workers. The wage rate per day of non-skilled worker is cheaper and have a same rate even different group of works. For our project, there are 9 skilled workers and 12 non-skilled workers. The scope of skilled worker on site include operating all machineries, concrete builder, welder, pipe installer, or drainer, while the non-skilled worker scope was lifting and moving piles, mixing concrete, lifting the reinforcement, and other general labor. The wage rate for the labor per day based on the locality of Pahang. The skilled worker of machinery operator pay with 105 ringgit per day, and the duration of project is 180 days. 5 machinery operator, thus the total cost with 94,500 ringgit. For the builder rate was cost 95 ringgit per day and cost 18,000 for this project. Third, there are true blacksmith and welder wages which 85 ringgit per day and the total cost with 30,600 ringgit. Lastly, the pipe installer or drainer's wages is 75 ringgit per day, and there were just one installer and cost 13,500 ringgit for this project. Thus, the total cost for skilled workers is 156,600 ringgit. For the non-skilled workers, wages is 65 ringgit per day, and there were higher 12 general labors and cost 140,400 ringgit. The total cost of workers, including skilled workers and non-skilled workers, is 297,000 ringgit, and the total cost for skilled worker is higher than the non-skilled worker. The percentage of workers' cost is 1.33% from the whole total cost for this project.
So now I'll be continuing to the site management part of our project. So in our project, we have been carried out some management system which is suitable for our bridge project. So we have the safety management, waste management, materials management, plant management, and the labor management. So first of all, let's talk about the safety management. So the safety management is to give a prevention to all the risks and accidents that may happen during the construction of the project. So it is very important for the construction working site, which have the very high risk and uncertain dangerous compared to the other industry. So in our project, we have taken several steps and actions as the safety management for our project. So first of all, we are having the analysis of the site hazard and we will figure out a solution for it. So before a construction site working started, the hazard analysis is carried out to propose an arrangement or planning as a precaution step to the site hazard. Like for example, the common hazard that can be found on site is the accidents of falling from height, the collapse of the scaffolding, or the electrical shock, and etc. So we will figure out the suitable solution to prevent the happen of such accidents. Like for example, to prevent the collapse of the scaffolding, we will make sure that the installation of the scaffolding is installed with the guardrail, toolbox, and also the braces with the proper weight. And then next, we will also provide a pre-training program for our workers. So this is because we need the workers know that how to protect and prevent themselves from the possible dangers, and we also need them know the proper procedure for them to carry out the works on site. So this can reduce the risk on site and increase the awareness among the workers. Like for example, they will know the importance to wearing the safety helmet, safety jacket, and safety boot on site. So we also will giving the briefing about the safety requirement and the correct ways to operate the machinery plants. So this can avoid the accidents that are caused by the improper operation of the machinery, such as the excavators and also the crane. So next, we will having the emergency preparedness. So for example, we will install the fire extinguisher and also the first aid box on site, and we will also properly plan the excavation for the emergency, such as the happen of the fire accidents on site. So next, we will also make sure that the communication on site is always active and effective, so the workers can call for the help when any accident happen as soon as possible. And we will also install the warning signage as a reminder and also increase the safety awareness among the workers. And then next, we will be monitoring the safety performance on site. So the site supervisor will be frequently carry out the site inspection to ensure that all the safety regulation is followed on site. So he also need to make sure that all the workers that enter to the site must wearing the required safety equipment such as the safety helmet, safety jacket, and safety boot. And the site supervisor also need to track frequently and daily about the equipment and the machinery to use to detect any possible damage before the using of the such equipment. So the equipment is properly installed and used by the worker is also need to be identified. Like for example, if the worker need to climb up to the higher places, need to make sure that the workers is using the proper scaffolding to climbing up and not climb up upon some movable objects such as the bricks and rocks on site. And then lastly, if there is unfortunately happen any accidents on site, so the project team must be carry out the investigations on the accidents as soon as possible. This is because the happen of the accident indicated that the safety management is still inadequate and it requires the improvement and need to make a review to the division head of the management system. So by having the investigation, you can identify the possible dangers that might not noticed before and can figure out a solution as the prevention for the same accidents to happen again in the future. So this is the procedures for the safety management for our project. So in the pre-construction stage, we will having the hazard analysis and we will figure out the solution for the hazard, and we will provide a pre-training for our workers about the safety requirement and regulations on site. And then during the construction phase, we will prepare and install the emergency tools on site, and we will also ensure the communication system on site is active and effective. So, and then we will also install the warning sign as a reminder and increase the awareness of the workers. And the site supervisor will be always carry out the site inspection frequently and daily to make sure that all the rule and regulation on site is fully followed by all the workers. So if any accidents is happen on site, the project team need to carry out the accidents investigation to figure out the reason for the accidents happen, so that we can make a review on the safety management and to improve the efficiency of the management. And next is the waste management system. So it is to handle the waste that produced during the construction work, and the waste on site can be minimized effectively and reduce the pollution to the environment by having the waste management. So first of all, we will have the waste minimization step to cut down the waste that produced on site. So before the designing stage, we will require the designer to carry out the site study and produce an accurate design which is suitable to the feasibility and condition of the site. So this can prevent the happen of the waste of the material that caused by the improper selection of the materials and overpurchase of the material. But during the design stage, we will encourage the designer to select the prefabricated element to reduce the off-cut waste on site. And we will also reducing the using of the non-mineral materials such as the plastic material and the packaging material. While during the construction phase, we will always keep the site in a clean and tidy condition to prevent the happen of the overstockpile of the waste on site. But we also will protect the project materials from damage to prevent the waste of the materials, and we will separate the location to storage the project materials away from the location to collect the waste. So we will also categorize the waste into different types, such as the waste which is for the reusable and non-reusable waste, and recyclable and non-recyclable waste. Besides that, we will also encourage the workers on site to reuse the temporary work still in a good condition, such as the formwork and also the scaffolding. Besides that, we will also try to recycle the waste on site. So to make the recycling work easier, the waste should be collected in a separate container or the dumpster according to their types. So a material recovery facility is used as the waste sorting facility to recover the recyclable material. So the recyclable material can be changed to the other waste handler company, which will turn the waste material into another form as the manufacturer for the other project. Like for example, the rock or the stone can be crushed into the smaller size and become the aggregate which can apply on the other project. Well, if the waste is not suitable to recycle or reuse, so the last option is to dispose the waste from the site. So it will be disposed to the local authority place, and the contractor can contact to the waste handler company to transport out the waste material from the site with a dump truck. So the disposal must be carried out in a proper way which is obeyed to the law and regulation, because if the improper disposal of waste will cause the pollution to the environment, and this will cause the penalty to the contractor too. And lastly, we will having the monitoring of performance to the waste condition on the site. So to monitor and inspect the waste condition of a site, all the materials used and waste must have the documentation record. So the site supervisor or the site audit can immediately track and check on the amount of waste that produced on site when needed. And the site inspection to the waste material must be carried out daily to make sure that the waste will not overstockpile at the construction site. And we also need to make sure that the worker are using the proper ways to handle the materials to prevent the happens of the damage of the materials. Besides that, we also have the material management for our site project. So material management also can be defined as planning, identification, procuring, storage, receiving, and the distribution of the materials. So the material can be deteriorated or be stolen during the storage if the special care is not taken. If the supplies needed for specific operation are not available, delays and the additional expense can be incurred. So the master production schedule, inventory record, product component list are merged into this system to determine which item must be ordered. So why we need to have the material management? First of all, we hope to get an efficient material planning, and we want to control the buying and purchasing materials on site. And it can ensure that the material can procure and receiving safely by us, and it can have a storage and inventory controls on the materials. Besides that, the material management also can help to supply and distribute of the materials for the activity works that carry out on site. And it also can ensure the quality of the materials and identify the specification and standardization of the materials. We have three classifications for the material on site. There are bulk material, bag materials, and packaged material. This is the process for the material management. So first of all, we will having the material planning. So we will measure and schedule the material that are required for our project. After that, we will start to purchase the material from the supplier as per planning. So after all of this, we will start to prepare the storage for the material. The material with the different types will be located in the different area on site. Then we will carry out an inventory control, like decide the types of the ordering method and fix the order level for the material. So when the material delivery on site, we will receive it and carry out an inspection on the materials by checking the quantity and the quality of the materials. So we will also carry out a value analysis and standardizations on the materials. This is to reduce the number of royalties and help to find a lower cost alternative for the materials. So after all this stage, we will start to handle and provide the preservations to the material. So this is to prevent any damage on the materials happen. Now we are going to talk about the plant management. So it is used in the selection of the suitable type and size of the construction equipment, which will affect the amount of time, effort needed, and the productivity of a project on site. So if the plant management was carried out properly, the minimum breakdown is achieved and the plant on site is remain in a good condition with the lowest possible price. So this is the process that having the plant management on site. So first of all, we will having a choice of plant. So the plant which is suitable to use in our project will be selected. And next, we will have the controls on the chargings and order of the plant. So the site manager will consider that the regular internal rate for the plant and the equipment. And next, we will have the allocation and delivery stage. So we will have a central plant hire desk to manage requests for the plant delivery and allocation. And next, we will have the pickup and return after done using the equipment. So the plant is no longer in operation on site, can seek for an off-hire of the plant and any further charge. And next, we will have the preparation of the master maintenance schedule. So this is to show the scope and magnitude of each maintenance section of the repair and the construction task for a given time period. And lastly, we will have a maintenance on the plant. So it was required for all the plant to have a regularly maintenance and inspection to mitigate the damage problems. We have four types of the plant maintenance. So first is the corrective or breakdown maintenance, which is referred to the plant or equipment which have been out of order and it can no longer perform its regular operation. And secondly, we have the scheduled maintenance, which practice including the inspection, lubrication, maintenance of the equipment. And third, we will have the preventive maintenance. So it is to ensure that the plant or equipment is always available and ready for use on site. And lastly, we will have the predictive maintenance. So it utilizes the human sense or other sensitive resource such as the audio gauge vibration analyzer to predict the plant troubles. We have applied few techniques in the plant management. First is the accounting software. So this software allows the plant to be efficiently allocated, including availability by listing the plant and its related information. So at any given time, the related workers are then able to access the availability of the plant. So the site manager of this project will apply with this software to track and control the rising of costs and make informed decisions about the fleet management. And secondly, we have the IoT for the plant management. So it is basically the interconnection of daily device to the internet. It is automatically modifying the environmental control system to minimize the power usage when it is not necessary. So it can also track the plant for pending defect rather than conducting the regular calendar-based inspection and the device repair. And lastly, we also have the RootMap ERP's plant maintenance software. So it is to optimize the plant's operating efficiency and to determine where to invest and prevent unexpected plant downtime. So it allows the assessment and evaluation of the condition of the individual component for the plants and assign them to the preventive, predictive, or breakdown maintenance schedule. Lastly, we also have the labor management for our project. So labor is among the main part of the management that make the project completed in a due time. So labor management will boost the worker to perform at their best to make the project done with good quality, save cost, and best quantity. So this labor management involves with the human resource such as the recruitment of new employee, performance management, payroll management, bonus, insurance, or compensation for the employee. So for the labor on site, the labor performance is usually measuring by using the labor productivity. So the productivity of the labor is usually referred to the output per labor hour. Like for example, how many bricks that have been laid by the bricklayer per hour and how many cubic meter of concrete have been placed by the worker per hour. So the productivity of the labor is measured by how the worker convert the labor force into the useful output by utilizing the equipment and capital on site. So in the labor management, first we will carry out the selection of the quality workers. So we will make sure that the workers selected have the suitable characteristic like the suitable age and the body health. And we also selected the worker which have the related experience and job knowledge and can work independently on site and have the ability to work under the high pressure. This is to make sure that he can face for the tight working schedule when we need to rush for the project due date. And he also required to have a good communication skill and have a very high safety awareness. And secondly, we also very important on the safety for the workers. So the workers must be attend to the pre-training program to have a better understanding about the site safety and regulation. A constant time of assembly also need to be carried out among the workers to update the safety information to all the workers. Well, for the human resource management, first we will have the acquirement. So we will have a formal recruit after finding the right candidate for the job position. And secondly, we are very taking important on the engagement, satisfaction and retention for the workers. So this is to ensure that the workers can be feel satisfied, committed and stick on as long as possible. And lastly, we will also carry out the performance management. So this is to measure and complete the performance evaluation and allow the workers to have a consistently enhanced and reward outstanding work. So here is some important in the labor management. So first of all the laborers need to know the deadline of the project. And secondly, the size of the job need to be observed to make sure that it is fit well with the deadline. And thirdly, for the project managers or the supervisor need to get enough construction workers for the project based on the size and the deadline of the construction project. And lastly, the manager need to identify what types of the project that need to be done and what type of the expertise labor that he's looking for in order to get the effective result in the labor management. The advantage of the labor managing is to boost the construction labor's productivity and motivation. And secondly, it can improve the efficiency of the project workflow. And lastly, it can help to produce a lower labor cost and set up a fixed salary. So this is all by our group 6 about the Sungai Kepong Bridge project. Thank you for your attention and we hope you enjoy it.